Hello everyone, Mr. Minix my name, math is my game. It's been a long time since I've done this. I'm joined by my first period Algebra II class. They're really excited to be here. It's day 2 of opening day for the Cleveland Indians. Did I say Cavaliers? I started to say the Cleveland Cavaliers. Anyway, I don't think they're going to play today, but that's another story. So here we are, Chapter 6, Section 3. It's going to be a long day. I forgot to wear a belt. Sorry, you don't need to know that on the video, but I hope my pants don't fall down. Okay, 6-3. The title's probably the second worst of it. Binomial. Let's think about that. Bi means not 1, not 3, but 2. Nomial, that means there's 2 terms. Binomial radical expression. Binomial radical expressions. We're going to look at more than one. Believe it. Binomial radical expressions. Ready? Like radicals are like terms. Like radicals are like terms. Never knew you could use the word like 3 times in a sentence. 3 times in the same sentence. But it's true. Like radicals are like terms. I had a request to do the Batman voice. I honestly haven't watched a Batman movie in about 15 years, so I don't know. I could say I'm Batman, but I don't know. I could do the voice of my YSU professor who did the number 2. Any question? Okay, fine. Anyway, like radicals are like terms. What am I talking about? Let's think about like terms. 6x squared plus 3x minus 2x squared plus 4x cubed. We have some terms there that are like. Remember what's true of like terms. Like terms have the same what and the same what? The same variable and also the same exponent. Good. So if we look at 6x to the squared, I don't know if this is going to work. I'm going to try it. Maybe I'm wasting too much time because we have a lot to do today. But I think it'll be worth it. I know it'll be worth it. Okay, so if we look at the 6x squared, does it have a like term? What's like to it? The negative 2x squared. So consequently, we could take those 2 terms and do what with them? Mix them up, stir them up, and make some chocolate chip cookie dough batter. Or you could buy it from the track team. 4x squared, then what? Are there any other like terms in the expression? No. The 3x has nothing like to it. The 4x to the cubed, since it's a polynomial, since I'm doing something to it, I should probably put the 4x cubed out front, huh? So do we get what I mean when I say like term? We understand what like terms are, right? Well, let's look at some like radicals. Okay, we're ready? Okay, so here we go. Example 1. Example 1, simplify. Bless you, I heard someone sneeze. Simplify the square root of 7 minus the square root of 8 plus 3 times the square root of 7 plus 5 times the square root of 2. Now, right off the bat, we should be able to recognize 2 of these terms. If we weren't looking at our cell phone, we could. We should be able to recognize 2 of these terms as being like. Which 2 are like? The rad 7 and the what? And the rad, no, not the rad 7 and the rad 8. What are we thinking? The 3 rad 7 and the rad 7, right? Remember what taking the square root of something is like doing. It's like raising it to a power. It's like we have 7 to the 1/2 power. 7's not a variable, it's a constant. 3 rad 7, well, that rad 7, it's like raising it to the 1/2 power. So we have the same, imagine that we're an x, we have the same variable and the same exponent, don't we? So do you see what I mean when I say like radicals are like variables? Okay, so because of that, because like radicals are like variables, we can combine them. So how many rad 7s are we going to have? We have 3, let me get my magic marker going. We have 3 of them over here, right? To that 3, we're adding this. How many are here? 1. So how many rad 7s are we going to get? Good. Does that make sense? All right. So we get 4 rad 7s. Now, if I were ordering Chinese food from the Main Moon restaurant, and it's the end of my order, you know what they're going to ask me. And of course, there's something else. Rad 8, I hope and pray that somebody in here can tell me how that simplifies. It's got a factor in it that's a perfect. Isn't 8 really 4 times 2? And the square root of 4 is 2, so a 2 pops out, so that's really minus 2 times the square root of whatever's left. If a 2 pops out, the other 2 stays under. So now this minus 2 rad 2, does that have anything that's like to it? The 5 rad 2, it's like to that, right? So those are like now. So if we have negative 2 rad 2 plus 5 rad 2, what do we get? 3 rad 2. So that's the way, I like it. So that's it. That's our final answer. Now, have we ever been able to take x's and y's and add them together to make x, y's? Do we ever do that? No. So because of that, this is it. At this point, we step. Okay? Let me spell it that way. We step. For those of you from Cleveland, we step. That's it. Don't make up crappy rules. Crappy rules are not good. It's not 7 rad 9, because 7 rad 9 would be 7 times 3, which would be 21. And 4 times the square root of 7 would be like a little bigger than 4. It might be like 8. And 3 times the square root of 2 might be like about 4. And 8 plus 4 is clearly not 21, is it? So the point is, that's it. We can't go any further. How do we feel? All right? Okay. Well, let's look at something else. Let's look at example 2. Example 2, binomial radical expressions. What if we had something like the square root of 3 multiplied by the group of the square root of 3 plus the square root of 4 plus 8, something like that. Oh, this reminds me of working on my Ford truck. It's a 96. I don't know if anybody knows anything about 96 Ford trucks. But their ignition system isn't the same as the new trucks. The new trucks, anybody know how their ignition works? It's all controlled by a computer. My 96 is also controlled by a computer, but it has this one thing that back in the day when you did a tune-up, you had to get a cap. What kind of cap? You had to get a rotary button to go inside on the top of the... No, none of you work on engines or tune them up. You don't know what you're missing. What property am I going to need to use here? The distributor property? Let's talk about a distributor cap and rotors and wires. We're going to use a distributor property here, right? Well, let's see what happens. This is going to be interesting. Oh, hey! Boy, that sounded like the laugh from that person from Tales from the Crypt, didn't it, there for a minute? You probably don't know what I'm talking about. I could do something before I go any further. Who sees something that I could simplify? What do we think? Couldn't I simplify the what? The 4, yeah. The 4 is really going to be 2, right? Now, I heard somebody else say combine like terms. Well, there's no like terms to combine yet, but I could make the 4 a 2. Is that fair? Okay, so let's go ahead and do that. So this is really rad 3 times the quantity rad 3 plus 2 plus 8. Oh, this is going to make this so much easier. So that's rad 3 times the group of rad 3 plus how much? 10. Now we distribute, and it's kind of weird. It's kind of ironic. It's kind of like hyphenated. Anybody ever think of the word hyphenated? I'll show you something in a second. So let's distribute now. What's the square root of 3 times the square root of 3? That's the square root of 3 times 3, which is going to be the square root of 9, which is going to be 3. Okay? What about the square root of 3 times 10? 10 times the square root of 3. Now, it's kind of interesting, it's kind of weird, but this is our answer. 3 plus 10 times the square root of 3. We can't combine those. We can't combine them. It's like having x's and y's. It's like having 3 plus x. We can't combine those, and that's it. It's kind of odd that the first thing ends up being just a number, and the last thing ends up having a radical in it when it didn't. It's like the word hyphenated. And you might say, how so? Look at the word hyphenated. Hyphenated. Is there a hyphen in that word? You want to see something ironic? The word non-hyphenated has what in it? Oh, the things you see on Facebook. Okay. What example are we on? 3, 4, 5. Example 3. Simplify. Oh no. 3 plus the square root of 6 times the group of 6 plus the square root of 3. Oh, I sound like I'm going to die. Someday, hopefully not today. Okay. Oh, I could call the social studies teacher, and he would know how to do this. I really wish I could patch the phone into this. What social studies teacher? Mr. Massey. And he would say, you know, Minnick, I know how to do that problem. You use what method? The FOIL method, sure. What is the result of the F part of FOIL? We multiply the first terms. We multiply the 6 and the 3 and the 6, and we get 18. Awesome. What's the result of the O, or the outer terms products in foiling? Three rad 3. What is the result of the product of the inner terms when we FOIL? 6 rad 6. We're getting it now. We're on to something here. And then the product of the L's. Now this is going to simplify I almost said the S word. This is going to simplify a ton. It's going to be the square root of 6 times the square root of 3, which by our properties is the square root of 6 times 3, which is going to be the square root of 18. But isn't 18 really something times something? 9 times 2. So what's that going to end up being? 3 rad 2. That's going to end up being 3 rad 2. So we got 18 plus 3 rad 3 plus 6 rad 6 plus 3 rad 2. You can combine the... Oh, I copied something wrong. If this had been 6 rad 3, you could have combined that with this, but I made an error. That's my very bad. That's actually 6 rad 6. So now, we're done. It looks like a stinking mess. And I really wish that people would stay off their phones, because I'm about to take them, and I'm going to put it on video. Next time I see it, I'm going to call it out to the world. So please stay off our phones. So 18 can't combine with 3 rad 3. 3 rad 3 can't combine with 18. Can't combine with 3 rad 2. Can't combine with 6 rad 6. And you might say, but wait about this, and this have the same coefficient. Yeah, you're right. But what has to be true for like variables to be combined? They have the same variable and the same exponent, right? Well, I got news for you. Those aren't like variables, and we can't combine them, and then that's it. That's it. We feel all right? Okay. Well, we're far from being done. Yeah. Example 4. Oh no, that's going to disappear in 5 seconds. 4, 3, 2. It's the magic marker, sorry. Example 4. Let's multiply 3 plus rad 7 times 3 minus rad 7. 4th 9 weeks. An exemption from the first quiz. I'll give you an automatic 100%. Who can tell me how those two quantities relate? I'll give you 30 seconds to think about it. I saw your hand first. They're difference of squares. I like that answer, but it's not what I'm looking for. But I will give you 5. Let me jot that down. 5 bonus quiz points because that's a pretty good answer. Sam? They'll cancel? That's a good answer, but it's not what I'm looking for. Aren't they like absolute values? It's a good answer, but not what I'm looking for. What did we say? Are you serious? We got a winner right here. We got a winner right there. So we got some bonus points here for a good answer. We got some bonus points here for a good answer. But the winner, chicken dinner, first quiz, you get 100% on it. Nice job. Say it loud for everybody to hear.
They're conjugate pairs.
They're conjugate pairs. They're conjugate pairs. These are conjugates. They're conjugate pairs. Now, on your midterm, you had to multiply conjugates. And the dealio is when you multiply complex conjugates, the product ends up being real. When you multiply irrational conjugates, our one answer, somebody said they're going to cancel. Yes, they're going to cancel, but what cancels is the irrational stuff. So the answer ends up being rational. Does that make sense? Okay, so let's see what happens. Again, we could call the social studies teacher, and we're going to use the FOIL method. 3 times 3 gives us 9, the mad German. The O part of foiling gives us how many rad 7s? Be careful. -3 rad 7s. The inner product of foiling gives us how many rad 7s? 3 rad 7s. Is it plus or minus 3 rad 7s? Plus 3 rad 7. Oh, we have -3 of something, and we have +3 of the same something. Guess what happens? They cancel one another out just as we suspected. Good. On the final product, this is where the magic happens. Rad 7, rad 7. This reminds me of Jim Carrey in that one movie, Pet Detective. What did they call him? What was his nickname? They always said it twice when they said it. Never mind. Forget it. It's not worth it. So we get minus rad 7, rad 7. Can't we play squeeze play with the rad 7s? So that's minus rad 7 times 7, which is minus rad 49, which ends up being what? It ends up being 7, right? So what we've got left is 9 minus 7. So it's just 2. Ha ha! Cutting. The final answer is just 2. Hey, wait a minute, just 2. That's rational now, isn't it? Just like we said. Just like we said. You can believe that that will be an essay question on your next quiz. Describe what happens when you multiply an irrational binomial by its conjugate pair. You get a rational answer. Got it? Okay. Good. Well, let's look at one more, and then that'll be it for today. I always save the best for last. I'm like Vanessa Williams, like that. Sometimes. I can't wait until I get over this illness. I'm down with the sickness. At least I don't have what they have at Wyndham. That sugarlosis. Anybody come down with that stuff? That was bad. Okay, who thinks we could cancel the ones? I didn't see a single hand go up, and I'm so glad. I got to give a shout out to my boy, Dr. Jones, for educating you the right way. The ones can't cancel because of Chapter 8 concepts that we studied, interestingly enough, before Chapter 6, but I think it was a good thing that we did. So the ones can't cancel. So Houston, we have a huge problem. Denominators with radicals are kind of like freshmen at the senior lunch table. They shouldn't be there. And I don't have any disrespect against freshmen, okay? But denominators with radicals are bad. They are bad. Can I write it like that? They're bad. We're not allowed to have them. It's not simplified. So, wouldn't it be nice if we could make the denominator rational? So how can we make the denominator rational? How do we make an irrational expression, an irrational binomial expression, rational? Not with exponents. Multiply it by its conjugate pair. So we're going to multiply the denominator by its conjugate pair. What's the conjugate of 1 minus rad 3? 1 plus rad 3. All right, all right, all right. I feel like I should be doing a Lincoln commercial and rolling my boogers in my hands. That's what he's doing. Just watch it, you'll see. Now, what happens if we multiply just the denominator by something? It screws up the whole thing, doesn't it? So we really have to multiply by 1. In other words, we multiply by something over the same something. So in the numerator, we also have to multiply by 1 plus rad 3 as well. That whole expression is 1. It's not going to change the value, but it is going to modify and make our denominator awesome. Awesome sauce, as my friend would say. What do we want to look at first, the denominator or the numerator? Denominator. We know what's going to happen, right? In the denominator, we're going to get 1 times 1 is 1. We're going to get minus rad 3 plus rad 3. What happens there? They cancel. What's going to happen on the end? It's going to be minus rad 3, rad 3. Minus rad 3, rad 3. What's that going to be? I heard of rad 9. I like the rad 9, but it's going to be what rad 9? Minus, because it's a negative times a positive, so it's going to be minus rad 9. And what is rad 9? 3, so it's going to be minus 3 in the bottom, right? So it's going to be 1 minus 3. 1 minus 3 in the bottom. Well, what is 1 minus 3? 1 minus 3 is how much? Negative 2, right? Okay. All right, we're almost there. We got to FOIL the top. When we FOIL the top, 1 times 1 is going to give us how much? 1. The outer terms, 1 times rad 3 is going to give us rad 3. 1 times rad 5 is going to give us rad 5. And rad 3 is going to give us rad 5 times 3, or rad 15. So what we get is 1 plus rad 3 plus rad 5 plus rad 15, and it's all over 2. You could write it just like that, and I would be happy as Meadowlark Lemon. I would be happy as a little girl. I'm sorry if that offended anybody and it sounded sexist. I don't know. It just came to my mind. I would be happy as, what do they say, a kid in a candy store. I would be as happy as I would be tomorrow if 90% of you do your homework tonight. So anyway, that's it. It's been real. It's been fun. I hope it's been real fun. I would like to give a shout out to Cole Dean. Cole Dean was the winner of our quiz exemption. Also, I'd like to give a shout out to Haley Stebner and to Sam Guyette, and to Zach Ober, and to almost everybody else for paying attention. I'm not going to name the cell phone violators, but they know who they are. Have a great day. Good.